So today we have a very special guest, Dr. Keaton Morgan. He's an ED doc, he's a practicing clinician, and he has done amazing things with informatics, especially related to clinical decision support. I will let Dr. Morgan introduce himself, and then as hosts, we will go around the room and introduce ourselves.
Perfect. Yeah, thank you. So I'm Keaton Morgan. I am an assistant professor at the University of Utah. I split my time between the Department of Emergency Medicine, where I'm a practicing emergency medicine physician, and the Department of Biomedical Informatics. I have a number of roles in the institution, in addition to my clinical role, which includes also being the director of informatics for the emergency department. And then I am also a lecturer on a few of our informatics courses through the Department of Biomedical Informatics. And I appreciate the time to join you all today. And I'm sorry I could not be there live.
Thank you. So you wear multiple hats,
Yes.
as probably happened. Teri?
Hi, my name is Teri Sippel, and I'm an adjunct professor at Johns Hopkins School of Medicine, teaching fire and interoperable clinical decision support with Krishnaj.
Thank you, Teri. So I'm Krishnaj Gourab. I'm a rehab doctor by occupation. I'm the chief medical officer at University of Maryland Rehab and Orthopedic Institute. I hold faculty appointments at Hopkins as well as University of Maryland. And also boarded in a clinical informatics subspecialty. So this is really a very interesting and very pertinent topic for me, and I'm really excited about it. So because I'm excited, I read Dr. Morgan's paper a couple of times. It's an excellent paper. It was published in August of 2022 in JAMIA. So please check it out. Even though I have read the paper, and I would request Dr. Morgan to describe in his own words the cool things that he did. Important takeaway, and this is that this was actually implemented in a live clinical setting. So yeah, go ahead, please.
Yeah, so I will start with kind of what was novel about our paper. And I like to think of it in kind of two separate buckets. One, we have the clinical goals of the study, and the second part is we have the informatics goals. From the clinical goals, you can really boil it down to we're trying to reduce waste in medicine by decreasing the number of unnecessary imaging tests that are ordered. And you can think of that as you have these collection of these risk stratification rules that you can apply to patients. And by using these rules, you can say, I'm seeing this patient in the emergency department, and by applying these rules, they meet all these criteria, and I know they are very low risk for disease process A. And because they are so low risk, I do not need to get a CT scan or an ultrasound, these expensive tests, to rule out that process because they're so low risk. And from a clinical standpoint, I would say that this study did contribute to the already existing literature on it, but it wasn't necessarily novel, I would say. But it was still an important contribution. So that's from the clinical part. From the informatics part, I think it really was a very novel study, and really, I think, moved the needle forward as far as the implementation of standards-based clinical decision support. So we have these rules that we want to be able to show to the user to say, you should think about using these because these can help add value to patient care and decrease waste in medicine. And the way we did that, though, was by using these clinical decision support standards, most notably Smart on Fire and CDShooks, to be able to implement it. And it's novel because this was the first study ever that used CDShooks to be able to recommend the use of a Smart on Fire app in a live environment. And so we had a Smart on Fire app that contained all of these rules that I mentioned before, these risk stratification tools. And that app was available in our live environment. And we used then CDShooks, which is the CDS standard, to be able to recommend the use of that application, to say, hey, think about using this application that's available to you in the EHR. That, by the way, is being managed by a third party. That's not part of the EHR. And this was the first time that that's ever been done in a live environment. And secondly, is that this was the first time that we had a randomized controlled trial using CDShooks in a live environment at all. And it showed that, hey, by using CDShooks, you can increase the use of this Smart on Fire application. So I think those are the major novel contributions that this study made. And it's mainly, like I said, in the informatics realm.
Yeah, I think that was an excellent summarization about what was the novelty of the study. So to understand the novelty more, can you describe a little bit? You mentioned that the novelty was that you were pulling in an application that was hosted by a third party that was outside the EMR. Before you implemented this, or even now, what is generally the standard? Like, what is the prior state, or what is the current general state about how CDS is implemented? And then after saying that, if you could just describe what are the advantages of implementing it in this manner, that is, the CDS is being made by somebody else outside the EMR, then pulling it into the EMR.
Yeah, that is a great question. So I'll answer the part about what the standard is through an example of some firsthand experience I had, which is, so I'm, as the director of informatics for the emergency department, get involved a lot with pretty much anything informatics that's implemented in our emergency department. And we had a researcher who was doing a collaboration with an outside institution. And part of that research study was actually implementing a different alert into our EHR, different than our study. And with this alert, the other institution used Epic, which is the same EHR vendor that we use. And to implement this alert that they created, they essentially handed us a Word file that was probably 20 or 30 pages long of all these screenshots of how they designed this EHR on the back end, like the technical specifications of the alert and how to create it. And so even though they'd already created it for their institution and we're using the exact same EHR vendor, we probably spent about a month between an analyst and myself duplicating the work that they had done. And you think of that as far as how much money that is. Between two people taking a month, that's tens of thousands of dollars spent just duplicating work that's already been done. And so that, I would say, is the current standard. And then when you go outside of the same vendor, and again, that's the same going from Epic to Epic. Imagine if you were going to Epic to a Cerner or another EHR vendor, it gets infinitely more complex, because the question is, well, what if this functionality isn't even possible that we did here at institution A that has this EHR vendor? And if that functionality is not existent here, then what do you do? So then it gets infinitely more complex as you try to go to more EHR vendors. And that, I think, is the advantage of CDShooks. So one is, and that's scalability, that you can create something, and instead of having to then hand over a paper and say, this is how you build it, you've already built it. Instead, they're just trying to make that connection between the hospital and the CDS server. For this, it would be CDShooks. And once you do that, then you can go from hospital to hospital, just making those connections, but not duplicating all of that work. And the other would be enhanced functionality, so that you have the ability to then do things, more complex logic outside of the EHR than you can within it. So for example, if you were doing a study that was trying to predict disease process X, and you want to use machine learning techniques to do that, which is, I think, becoming very common now to try to use for predicting disease processes, making diagnoses. It can be very difficult to do that within an EHR. But with something like CDShooks, where you take that data outside, and then you can run more complex logic and then put the output back to the EHR, you can do much more complex things and do that across EHR different vendors. So those, I think, are the two primary advantages, are scalability and increased functionality.
Great. So let me ask you something, and then I'll probably hand it over to Teri, because I'm sure that she's also thinking of some questions. Now that we know the advantages, let me pretend that I am a patient. I walk into the ED. I have a head trauma. And then if you could just walk me through the sequence about you are the ED physician, you open up the EMR, then what happens that ultimately leads to you as a clinician seeing this application displayed within your EMR. Is that okay?
Yeah, that's great. I love that approach of kind of walking through. So if I'm a clinician, I will walk in, I will see a patient, and I'll take a history, and then I'll go back to the computer. And as I'm going through this process early on in the workup of evaluation of the patient, I'm coming up with a differential diagnosis and trying to determine, what's most likely and what orders do I need to test in order to help me determine what the diagnosis and really disposition of the patient is. So I get back to the EHR and imagine I'm seeing you said with head trauma, I believe.
Yeah.
And so at this point, it's okay, what do I think the risk is that there is some serious intracranial pathology, so like a head bleed, that we would need to be able to identify. And one of the rules that we studied was called the Canadian Head CT rule. And that is a risk stratification tool. And there are a number of criteria there that if they meet all the criteria, you can say you are so low risk that you do not need to get a head CT. And so what we did in this study is that we used a chief complaint and then a few other criteria, including age of the patient, to make sure that they meet criteria for the rule. And if they met those criteria, so they had a chief complaint that was related to trauma, so they were in a motor vehicle accident, or they had a chief complaint of head trauma, then they, on the side of the EHR, as I sit down to put in orders and potentially order a head CT for that patient, there will be a prompt on the left that says, consider ordering a head CT. Now, what happened in the back end of that for us to see that prompt? What has happened so far is that we have a hook on the side of Epic so that when I open that patient's chart, it then sends information in connection to CDShooks, an external server. And that went through a FHIR server. So moving through a FHIR server has gone to CDShooks and essentially prompted the server and sent the relevant information in that said, we now have a patient in the emergency department. This is the context. This is who the provider is. And this is the relevant patient information to this encounter. And then from the CDShooks side, it is now doing the logic to say, some additional logic of this patient meet criteria for the prompt that we're going to display. And if in this case, the answer was yes, it then sends back information in the form of a card that says, this patient meets criteria, consider using the Canadian Head CT to potentially not get imaging for this patient. And on that card, what is called a Smart App Link card. And what it does is a hyperlink. And by selecting that hyperlink, I can then automatically open up the rule itself in a Smart on FHIR application. And so the MDCalc app opens up. And that also works through the FHIR interface. So FHIR is a data exchange standard used both for CDShooks and for Smart on FHIR. And so then I can open the rule itself and look to see, and there are additional inputs that I manually have to put in that you can't get from the EHR, such as like what was the mechanism of injury? Was it high risk or low risk? How high speed was the car accident? It was a car accident. And from that, then I can go through that calculator and determine this patient is low risk. I don't need to get a head CT. I'm not going to order one. And so all of that whole process then happened through both using CDShooks and Smart on FHIR. And to the user, they have no idea that this is an external server or an external service. To them, everything seems native within the EHR. In fact, most of our providers, I would say, don't even know that MDCalc is an external application, something third party, or that these prompts were from something else other than Epic. It is truly seems native to Epic, which I think is a really important part of it.
Thanks for the explanation. I mean, that makes it very clear. So as you were talking, I was also thinking that there's potentially one more advantage to having this kind of a mechanism where there is a third party who's sending the app. So let's say, and I don't think this is not going to happen, that the Canadian head city rule is going to change. But let's say we are bringing in an app that needs updating. As long as the company that has made the app keeps the app updated or the recommendations updated, every institution across the country does not have to spend engineering dollars in updating their site, right?
That is absolutely right. And I think that probably a lot of institutions underestimate just how much cost there is and resources go into clinical decision support and maintenance. And so you have these, medicine is always evolving, and the evidence changes, and practice guidelines change. And whenever that happens, then the burden of updating those decision support for the institution falls on the institution itself. And that can be really a lot of work in maintaining that over time, especially as you build a more robust decision support program. And you can imagine some have tens of thousands of alerts that they are managing for their institution, and keeping that updated with the current literature can be a lot of work. But if you have an external organization that is doing that for, let's say, hundreds of different hospitals, then that decision and that burden falls on one organization as opposed to thousands of organizations. And that is really, I think, a huge advantage, is the maintenance cost, that you can really reduce that with something like an external service, like using CDShooks.
Okay. I know we are going to talk about disadvantages later, or potential pitfalls and your experience with that. But Teri, did you have a question? I know I'm sorry, I'm hogging all the questions. So go ahead.
I have a follow-up question to what Keaton just said, which is, with all the talk and all the discussions about physician burnout and nursing burnout and all the staff and all the issues with staff, it seems like if we could alleviate some things like clinical decision support maintenance, maybe not the policy making of accepting which CDS rules to use, but the CDS maintenance of it, it seems like we'd be able to free up resources to do things like patient care. Is that true, or is that?
Oh, I definitely agree. And that I think that there's a lot more that our clinicians and other staff are doing besides just patient care. And I think a lot of people will see that stuff as maybe not where they want to be spending their time, right? That they have all these administrative responsibilities that they have to spend time on. And things like this, these are, I think, the technologies that can potentially reduce that burden of spending time doing things that's outside of patient care that people don't want to be doing.
So my question for you actually was, and I thought this project was fascinating. In table 1, you have some app suggestion criteria about in terms of which apps get called at which time. And I found that to be fascinating for a couple of reasons. One, it was actually more simplistic than I thought that it might be. I was expecting, pages of rules. But my question actually is, did you program this suggestion criteria as to which app to select? Was that programmed in the electronic healthcare record? Was that programmed within the app so that the app would be called a lot, but perhaps is often returning a null array? Or how did that work? And what did you learn?
Yeah, so we had a choice to make with that, and we kind of went right down the middle with it. And so if you look at the two extremes, I think kind of what you're asking is, how much logic do you want to have on the native EHR side to produce doing some of that for you, and how much do you want to have all resting in the external service, CDShooks? And if you look at them, you could say, okay, we could send everything to the external service. And also, it's important to note that our hook, so what the trigger was to look to see, does this patient meet criteria, was on chart open. So every time a clinician opened a chart, that would be our hook. And so you could say, okay, if they're in the emergency department, or you could even go further back from that. You could say, anytime a clinician opens a chart of any patient, we want to send a hook to CDShooks, and then have everything resting in CDShooks. And that would be, okay, where is this person? Are they in the emergency department? Is this a physician who's seeing this patient? and look at the other criteria that are relevant. What is their chief complaint? What are their vital signs and other criteria? That would be everything laying within CDShooks. The downside of that approach is that if you can imagine, if we did that across the entire institution, you're now getting millions of calls to CDShooks every single day. And you run the risk of performance issues with your EHR, which I'll say we have not run into, but that is the risk that you're running, is kind of overloading the server, and then performance of, now when you load a patient chart, it takes a while for that chart to load because it's calling out to that external service, and that's taking a while because it's getting millions and millions of calls. You get to the other approach, which is, okay, well, we want to reduce the calls to the service. So because of that, we're going to put as much logic on the side of the vendor as possible. And so we can do everything we need to that we can possibly do in the vendor, and then we won't call anything, only if we really need to, we'll call the CDShooks service. And so you could say, okay, we only want it if they're emergency department patient, if they meet this chief complaint, if they're this age, if they have these vital signs, then send it to CDShooks and have it do the remaining logic. You are right that in our study, our logic was not that complex. And part of that was by design, that we wanted to capture as many people as possible. And we can get into that later as far as why we made that design choice. But it was that we wanted to be more sensitive and know that we're going to be showing this alert for people that it doesn't really meet criteria for. You can imagine, though, if you were doing something more complex, that you can potentially do that. You would have a need that you would have to do more on CDShooks service. Like if you were doing something machine learning, you would have to. We didn't have to do really very much. We weren't forced to on the CDShooks service side. So we ended up doing something down the middle, in that we did some very simple logic on the EHR vendor, the Epic side. I think we did like patient age and their context. They were in the emergency department, but then we let the CDShooks service handle the rest, so that we reduced the calls to the service somewhat, like maybe, just guessing, maybe 50% we could handle on our side and know, well, we know these aren't going to meet criteria, so let's not even call the service. But we still let the service handle some of the logic itself. So I think it'll depend on kind of what the goals are, and if you're noticing any kind of performance issues, which again we hadn't during our implementation of this. So we just did it more preemptively, and then also what the relationship is between the organizations and how much effort you want to be on the CDShooks side. So if you could imagine it's a company that's running this and they're going to thousands of organizations, the easiest thing for them is to have complete control and do as much as possible. And so that when they go to implement, they say, hey, all you need to do is make this connection. You don't have to build this additional things in there. We'll handle everything. And so I think that is kind of the gold standard, but you do run some risks with that if you're doing extra calls to the service itself. I hope that answers your question.
Totally. That's exactly what I was looking for. And by the way, you're right. It's location, chief complaint, and age seem to be the three critical things that you were checking prior to calling a service. So you were doing almost like a course evaluation, a very rough course evaluation before calling the CDS service. So I can see how you're still eliminating quite a few of the calls. Yeah. And then my follow-up question was, for the six, you selected 6 different calculators. Could you just talk a little bit about, why you selected those 6, and then also your discussion about sensitivity versus specificity? I found that really interesting also.
Yes. So we chose those 6 really based off of perceived value. And I use that as a collective term, in that all of these 6, we call them calculators because that's the term that MD Calc uses, but they're decision rules is another term that you'll hear from them. But they're all very well-studied rules that I think are very well accepted across the emergency medicine community, that these are well-validated, and there's really not a lot of controversy about using them. Where the controversy comes in is that even though they're well-validated and been shown that if you use them, it's safe and you can reduce, waste, that people still aren't using them. And that's the issue that, the problem that we're trying to solve with clinical decision support, is to help remind them to use it when appropriate. So, there was a campaign called the Choosing Wisely campaign that you may have heard about, that they did and the goal of that was really to reduce waste. And for the Emergency Medicine Society, the American College of Emergency Physicians, they had a list of 10 things that they outlined for their Choosing Wisely campaign. And 3 of our rules came directly from the Choosing Wisely campaign. That they identified these are really high yield areas that are, common presentations for patients and well-validated tools to help reduce waste in medicine.
So were you logging? Oh, I'm sorry, go ahead.
Oh no, that was really, I think, our kind of the process of going to choose which rules. And we really wanted more common ones. There are a lot of decision rules out there, but if you're looking at one that, this is something that comes up, maybe once every, couple of months, I maybe will use this rule. These rules are extremely commonly used, or can be commonly used. I would say even of every single shift I'm working, I'm probably looking up one of these rules.
Oh, interesting. Just before the sensitivity and specificity question, when a physician was using this rule and potentially telling a patient that they did not need imaging, was that logged anywhere? I mean, I hate to say this, but in the United States, I can see how it could be, later, become part of litigation or something, and maybe it would give them cover.
Yeah, that's actually an excellent question, because that's part of the advantage of having the Smart on Fire app of MDCalc. So MDCalc is available both as a web application. You can search for MDCalc on the web browser, and you can bring up, and every single calculator that's available there, as far as I know, is available in the Smart on Fire app. You could also bring it up on your phone, on your smartphone app, same thing. The 2 advantages of the Smart on Fire app is one that is it autofills population. If you're on your phone, there's no way for it to know that, hey, the patient's age is 65. It's not connected to the patient, and it's not bringing in that data from the patient's chart. But with the application being integrated in the EHR, it is doing that. So it's automatically importing information from the patient's chart, is one. And then 2 is that one of the functions is once you complete a calculator, you can copy that information and then just with a copy paste, save that information into the chart. And that's a functionality that I think is huge, for one of them being the reasons that you mentioned, which is that to be able to demonstrate that, hey, I used this tool, I can prove that they were low risk in case something happened with that patient. And also, I think it has the ability to, in addition to like medical legal, would be to decrease the documentation burden, right? It's a lot easier. Like if you're doing that work anyway, it's a lot easier to copy and paste than to type out manually or dictate that I applied the Canadian head CT rule and they were negative. And then you also asked about like, the sensitivity versus specificity. So this came down really to, this was a difficult, I think, decision to make. And we could have gone anywhere on the spectrum. It ultimately came down to how we were displaying the alert. This was not a pop-up and interruptive alert. This was something that was shown in Epic. They call it the storyboard, which is a static column on the side of the EHR. And we didn't even call it an alert in our study. We called it a prompt because we think of alert as something, popping up and really getting your attention. This was just like a notification on the side, and it never interrupted their workflow. And because of that, when we really looked at the kind of pros and cons, we felt there's a lot of benefit to being able to show this alert. And as you increase the specificity, you're naturally going to miss out on some cases. And for us, that was, well, then they're getting these unnecessary imaging studies, which is a cost to the patient. The con was that it is going to be displaying on that side, and they could very easily ignore it. They never had to interact with that alert. Now, I think the risk that you run is, well, if they keep seeing that and 90% of the time it's not applicable, well, eventually they're going to stop paying attention to it. So that is definitely a risk that you run. And, it'd be great to get it perfect and that you're catching every single patient in 100% accuracy. But because we weren't doing an interruptive alert, we felt that it's probably okay to have it show too frequently. Maybe we would have made a different decision if it was a pop-up for sure, just because you really run the risk of like alert fatigue. And I think that would be happening much faster that people would stop ignoring it.
Perfect. Thank you. That makes a ton of sense. Krishna?
Yeah, as you were speaking, I was thinking like one of the other advantages could be like you are working in a university, I'm working in a university, Teri is also at a university. But let's think about the outreach of CDS can be substantially increased. Every place where healthcare is being delivered, if we have this distribution kind of a model. So, I mean, this is exciting. This is exciting. So, as it is exciting, we always talk about unintended consequences in in informatics. What are the potential pitfalls, or what are the things that could go wrong while we are implementing this kind of a model where we are talking about a interoperable CDS?
So that's a really good question. I think that the things that really come to mind for me as far as pitfalls would be thinking that every organization is going to be the same. And that, I think, and part of that is there's a quote that I really like from Reed Gardner, who's one of the pioneers of informatics. And he said that informatics is 80% sociology and 20% technology. And I love that quote because I think it's so true, in particular for clinical decision support. So I think that one pitfall is that we could have implemented this and had a successful implementation at the University of Utah and then think, well, we're guaranteed to be successful at Johns Hopkins or the University of Maryland or these other institutions because we've shown that it works at the University of Utah. And that's not necessarily the case. So even if the technology allows you for interoperability, that does not mean that you can necessarily apply this exact same thing in different institutions, even if the technical infrastructure is there. And I think that it's yet to be seen like how much work and how much change will have to be in between institutions because of this. If I came as a University of Utah clinician and went to Johns Hopkins and said, hey, I have this tool, I want to implement it. What is the trust level going to be there? Will they automatically accept it? I don't think we necessarily have the answers to that. And so I think that's one, I wouldn't say it's a pitfall, but I think it's a cautionary tale of you really need to probably have partnerships with these organizations and not think that you can just take a tool and automatically put it in some place and that it will be successful.
Yeah, that alone would be another interesting study.
Yeah, I know. But at some point of time, when we reach the gold standard, that let's say that I am looking at I just pulled up the PubMed, right? So, but PubMed, I mean, essentially, it's a HTML file that's being downloaded on my browser, right? I don't have to think twice whether it's going to work at University of Utah or Johns Hopkins or University of Maryland, right? It just becomes natural. So if we reach there at some point with CDS, maybe it will just become not even a thought, hopefully.
Yeah. And I think from the technical perspective, we're very close for that. The one thing that I think would be, another pitfall would be you still have to do code mapping. And even if you're going from one Epic institution to another, how they have coded their data or orders, tests, et cetera, is probably it's guaranteed to be different, even with the same EHR vendor. So it's truly not at this point plug and play. And so I think that can be a pretty easy process. There's some tools available that will help with mapping, but just don't think that you're going to be able to really, even from a technical standpoint, put it from one institution to the next. You're still going to have to do some mapping.
I agree. This what we described is probably 10 years, 15, 20, 100 years away, but hopefully we'll sometime.
I hope not.
Yeah.
Okay, I'm an engineer. So of course, one of the diagrams I found to be the most interesting was your system architecture diagram. And you go through the different steps and you're clearly getting the user involved as to when to display things. And you seem to take an approach that was much less, I think you called it non-interruptive even. Did you look at any type of clinical decision support that you would have felt that you needed to, be more interruptive, or was that part of the selection process that you said, no, these are the types of applications that we're going to use or going to try?
Yeah, it's interesting. So for our study, all of the rules were also similar in what their goals were. That we felt like whatever we chose for one, that we were going to choose for all of them. So they kind of came as a package. I don't think we kind of separated them into different pieces. And that decision, I think, ended up being pretty easy for us, that we just really did not feel that it met criteria for being a pop-up alert. What was hard about that actually was that we wanted to study it. And we knew that, well, we really have a higher chance of this being successful if we do it as a pop-up alert, that people are going to be more likely to use this application. But from a clinical perspective, we really didn't think that met criteria. And if from our institution's standards on what meets criteria for different alert types, it didn't. And so we didn't want to make, I think, it wouldn't have been as good of a study if we did something just for the sake of the study, which is that we really want to show that it makes a difference. So we're going to do in a pop-up, even though if we weren't doing this study, we would have it as a passive, non-interruptive alert. And I think that's an important part, that we went through all of our normal clinical decision support protocols to implement this, that I was the clinical expert. We still went to our clinical decision support committee. We had to get their approval. I had to get approval from our medical director. We went through every single normal step that we would have to do if we were doing this, not using if we were just using our vendor EHR CDS system, and if we weren't planning on studying it.
Interesting. So our last question to you is what message do you have to the Johns Hopkins students and anybody else who might be listening to this video?
I think my message, based off of kind of learning from this study, would be that informatics is such a collaborative field that I think that is like the most important thing as a skill that you can develop, is the ability to collaborate with other people. And I remember when I started my informatics training, I had this vision that I could do everything, that I could develop the Smart on Fire tool, that I could also be doing CDShooks and also be the clinical expert. And the reality is that it's growing so much, which is exciting, but it also means that you can't do everything yourself. And so as you're learning these technical skills and you're learning about the informatics tools that are available, I think the most important thing is that you're also learning how to collaborate with people who are experts in those tools, because informatics is inherently just so multidisciplinary. And that's something that I try to improve every single day, is being able to work with people outside of, emergency medicine, and also, non-clinicians and technical experts, and really being able to improve those working relationships, because I think it is absolutely key to your success in this field. And even within just our study, we had an academic institution who collaborated with a company, which was MD Calc. And on each side, there were 4 to 5 team members, each with their own expertise, and at the University of Utah to implement it. Even for people who weren't involved in the study, there was 4 or 5 team members to help with the implementation part. Like, collaboration is just key, and that's what makes, I think, informatics both enjoyable but also can be challenging.
Great point. I mean, this is probably so true for informatics. The other part is that, I often notice that informaticians, if you see a room of physicians in general sitting down, or clinicians sitting down, the happiest people are the informaticians, because I think they get the satisfaction of problem solving. I know I'm just kidding, but yeah, and they have to be nice. I'm sorry, go ahead.
No, I completely agree with you that there's just so much job satisfaction of part of this, the problem solving part, but also I think an understanding of the frustrations of, well, this is why the tool that you're using, for example, works like this, and this is what can be changed about it, or this is why this decision was made. And I think it just makes things so much easier to work with, and especially with the tools that you're using. So yeah, I love clinical informatics. It's phenomenal.
Yeah, let's even after this interview, let's keep on talking. I think you have to break down all barriers of collaboration.
Yes.
Teri, anything else from your side?
I just wanted to say thank you. I thought your paper was fantastic. And as Krishna said, I would love to continue to discuss all sorts of things. We really appreciate your time. And, it seems like there should be a way to get people like as Krishna and I were talking, our merry little band of people who are interested in teaching informatics together, and have some kind of a forum to be able to share information and ideas and videos. Krishna?
No, I agree. And thanks again. I would echo the same. Thank you again for taking the time to talk to me. This will be very helpful. Next time, we'll probably get you live with the students.
Yeah, of course. Thank you guys for inviting me. For your students, you're welcome to share my contact information with them, my email address. Again, I'm sorry I couldn't join live. That would have been fantastic. But if they have any questions afterwards, please have them reach out to me. I'm happy to connect with them.
Okay, sounds great. Thanks so much. Take care, everybody.
Okay.
Bye-bye.
Bye-bye.